Okay, good evening, Professor David J. De Los Reyes. Okay, my topic for tonight will be alternating current circuit. Okay, this will now be lesson number 6. Okay, let's proceed. Long-term video format, alternating current circuit, lesson number 6, and the title of the topic is actually how to add, subtract, multiply, and divide impedance. Because the foundation of AC circuit is actually impedance. Without knowing impedance, okay, there will be a problem. That's why we will try to bring out the fundamental operations and how to operate impedance, that is, how to add, subtract, multiply, and divide. Even the other parameters, current and voltages are all complex numbers. But for the meantime, we will concentrate for the meantime on the addition, subtraction, multiplication, and division of impedance. Okay, let's proceed. For the addition and subtraction are almost the same, except that when we are adding, okay, we write it in the so-called rectangular form, and when we are subtracting, we are also bringing out the impedance in the so-called rectangular form. So actually, addition and subtraction are actually similar. Okay? So if I will try to give you an example of addition, it's almost the same as in subtraction, except that the operation is subtraction. Okay, let's try to bring out an example. I give an example, maybe Z1, impedance is designated by capital letter Z. So I will be placing Z here with subscripts. Okay, so this is 1, 2, 3, 4, meaning impedance number 1, number 2, number 3, and number 4. The given impedances are actually Z1 equal to 3 plus G4. It's a combination of resistance and inductive reactance. Z2 will be 4 minus G6. It's a combination of a resistance. This is minus, so this should be capacitive reactance or a capacitor. Z3 is actually 0 plus G7. The resistance is 0, the inductance is plus G7, so this is a pure X of L. Okay. And Z4, unluckily Z4 is expressed in the so-called polar form. Polar form meaning it is expressed in terms of the magnitude and certain angle theta, meaning the direction. And for C4, the magnitude is 10, angle 45 degrees ohms. And the problem is asking what will be the summation. Okay. If the problem is asking that we should subtract C4 from the total, this will be minus. So that refers to subtraction. But the problem is just asking for the addition, so this is plus. Okay, let's try to bring out the solution. There is an additional requirement for the answer. We will take the summation of C1, C2, C3, and C4, and we must have to express our answer in polar form. So the problem is testing our knowledge on the so-called conversion from rectangular to polar or polar to rectangular. Okay, let's try to bring out the solution. To add C1, C2, C3, and C4, okay, the requirement for addition and subtraction is that they must be expressed in rectangular form. And luckily, C1 is already in rectangular form, also with C2, also with C3, but unluckily for C4, it is expressed in polar form, okay, and we must have to convert first this one to rectangular for it to be added to C1, C2, and C3. Okay, so to bring out the equivalent of C4, the magnitude is 10 ohms, the angle is 45 degrees. Okay, just draw your vector diagram. right? 45 degrees, this is 10, and this is 45 degrees, right? So, to bring out the rectangular form, there should be a vertical, horizontal component here, and a vertical component over here. So, actually, we are given a right triangle, in which the hypotenuse is 10, and this horizontal component is actually R, and this vertical component is actually XL. Okay? So it seems we are given a triangle in which the hypotenuse is given and the angle is given. So to bring out the horizontal and vertical component, we use the sine and cosine function, right? Okay, if you are on the board exams, if you try to convert 10 angle 45 degrees, you don't have to place anymore 10 cosine 45. It is just automatic, okay? You just place 45 over here. It's in degrees. Okay? Take the cosine. It's 0.707 times the magnitude. This is times 10 equals. It is 7.07. Okay? You just place it immediately if you are on the board exams or you are writing on your test paper. So actually, the real part is actually take the cosine of this, multiply by 10, that will be the real part. It is this portion here. Right? Take this angle here, press the sine function, multiply by the magnitude, that will be the imaginary part. Okay? You don't have to show it. Okay? It is understood that you perform the operation cosine and sine and bringing out the value of the real part and the so-called imaginary part. Okay? It's automatic already on your calculator. So you should know your trigonometric function. So meaning to say, 10 angle of 45 degrees, the equivalent of this in rectangular, the horizontal part is actually 7.07 and the imaginary part is 7.07. Okay? That's the first requirement for the operation, addition, or subtraction. All the impedances should be in rectangular form. Okay? So C1 plus C2 plus C3 plus C4, this is plus. Okay? Should be equal to C1 is 3 plus G4, C2 is 4 minus G6, Z3 is 0 plus G7, and Z4, the one we just converted, it is plus open quantity 707 plus J7.27. Okay, then apply your knowledge of the so-called fundamental operation, combine similar terms. So we go with the real part first. Open quantity 3 plus 4 plus 0 plus 707. Those are the real parts in one quantity. So we use the associative law, right? Plus J, open quantity. You combine all the imaginary part, okay? Taking into consideration all the signs, okay? So this should be J. The first one will be plus 4. Second one will be minus 6. Okay? The third one will be 7. And the fourth one will be 5 plus 0.707. All preceded by the G sign, meaning this portion is the imaginary part. Okay? Perform the addition. So this should be 14.07 plus J 12.07. Okay? So that is actually already our answer in real in the so-called rectangular form. But the problem is testing your knowledge of the conversion from rectangular to polar. So what do you do with this one? So it seems it seems we are given the real part, imaginary part. This is the real part. This is plus, so the imaginary part is upward. Okay? We are given this, and the problem is just asking for the impedance, okay, plus this angle here. So there's no problem. We are given the opposite side in the adjacent side. So we take the ratio 12.07 divided by 14.07. Okay, we divide this ratio here. The relation will be tangent. The quotient will come out inverse function tangent. Okay, so the angle is 40.62 degrees. Okay, that's automatic. You take the ratio of this one, what comes out, you press arctangent, the angle will come out, 40.62 degrees. And to bring out the magnitude, okay, the last time around, there is three possible solutions, right? You either use the cosine function, the sine function, or the Pythagorean theorem. But the simplest one, or the simpler of the three, is actually the sine and cosine. So we will take the cosine of this one, okay? We will divide this with the real part. So what comes out will be the magnitude. We will take the inverse of this. This is times 14.07 equals. The magnitude is 18.537. Okay, that's the first solution. Or you could take the sine of this one. You divide that with the value 12.07. What will come out will be 8.537. Okay, so the first two solutions are actually simple. But if you would like to use the Pythagorean what you call this theorem, it's a little bit complicated. You will be squaring this one, plus the square of this, take the sum, then take the square root. What will come out will be 18.537. So our final answer, okay, it will be 18.537, angle 40.62 degrees. The angle here is plus. So meaning the overall summation is actually an inductive load because the sign of the imaginary part is plus. So it is an inductive load. Okay, that's addition. Okay, let's go with multiplication. For multiplication, so you now know the requirement if you are adding or subtracting impedance. They should be all in rectangular form. That's the first requirement because you cannot add two impedance or impedances if they are in polar. You must have to convert them first to rectangular. Okay, let's try to bring out the multiplication operation for impedance. We are given C1 to be equal to 12 plus G8, C2 will be 5 minus G7. The problem is asking for the product of C1 and C2. And what will be equal to? It gives additional requirement. The answer should be in rectangular form. Okay, let's try to bring out the solution. For the operation multiplication, for it to be simple solution, okay, we must have to express both the impedance in polar form, okay? You convert first to this one to polar and also to polar. Because if you try to multiply this two here immediately, actually we could solve it, but it will take longer, right? But if you are in the board exams, the fastest way to multiply this one is to convert both impedances in polar. So converting C1, that's 12 plus G8. This is 12, this is 8, right? This is 12, this is 8. This is Z. So actually, this is 8. We take the ratio 8 over 12. Press arctangent. Okay? This should be 33.69 degrees. Take the cosine of this. You divide that to 12. What will come out should be 14.42. Automatic, using your calculator. You don't have to show it. Z2. It is 5 minus G7. The real part is 5. The imaginary part is negative, right? So it is pointed downward, meaning this is an x of c. So this is 5 and this is minus 7. So to take this angle here, it's same as this one, except that this is on the fourth quadrant. You take the ratio minus 7 over 5, right? This is more than 1. So supposed to be the resulting angle will be greater than 45 degrees. So you take the ratio 7 over 5, press arctangent. What will come out will be negative 54.46 degrees. Right? Take the cosine of this. You divide that to 5 using your calculator. Okay, what will come out should be 8.602 ohms, meaning this magnitude is 8.602. Right? So we are now given Z1 and C2 in terms of polar, so we can now proceed with the straightforward solution. Z1, C2 will be Z1 in terms of polar will be 14.422 angle 33.69 degrees multiplied by 8.602 angle minus 54.46 degrees. And the rule for multiplication of impedance or simply complex number is that you try to multiply the magnitudes, okay? Then you try the resulting angle should be the summation of the angle. So the resulting magnitude of the product will be 14.422 times 8.602. That's the overall magnitude. The resulting angle will be the summation of the angle. Okay, it should be 33.69. The operation is plus, right? So take note of the sign of the angles. Plus open quantity negative 54.46 degrees. A plus and a minus will be a minus. Okay? So this 54 is greater than 33.69. So the resulting angle of the product should be 124.058 angle minus 20.77 degrees. This is ohms. Okay? This is negative angle. So meaning the product is actually a capacitive load. And if we try to bring out the so-called rectangular equivalent of this one, it's the same. It is in the fourth quadrant, right? This angle here is negative 20.77 degrees. So this is the real part and this is the imaginary part. So just use your knowledge of trigonometry, use the sine and cosine function to bring out the real part. Take the cosine of this multiplied by the magnitude. What will come out is 116. And for the imaginary part, take the sine of this. Okay, multiplied by the magnitude. What will come out will be 44. This 44 here should be less than 116 because 44 over 116 is actually less than 1 because our angle here is less than 45 degrees. Okay, so this is our final answer in terms of the so-called rectangular equivalent. Okay, I will try to erase this one so it will look good. Okay, right? Even this one. Okay, so before we proceed with the operation division, okay, I will repeat it for the last time. Okay, to multiply two impedances, okay, if they are in rectangular form, convert them first to polar form, then perform the operation multiplication. So the resulting magnitude will be the product of the magnitudes, and the resulting angle is actually the summation of the angle. Angle of the first impedance plus the angle. The operation is plus if you are multiplying. Okay? So that's our final answer for the operation multiplication. Okay, the last one. For the operation division, we are given Z1 equal to 16 plus G8. That's the first impedance. This symbol omega, meaning it is ohms. Z2 is 24 minus J20, omega, meaning ohms. This is rectangular, and the problem is asking what will be the ratio of C1 over C2 equal to, but there is an additional requirement in rectangular form. To bring out the simpler solution of all the solutions, we should convert all the given impedance in terms of polar form before we will proceed with the so-called division. So C1 will be 16 plus G8. There is a 16 here. The real part is 8. This is 16. So this is actually the one we are looking for, the magnitude. Okay? So take the ratio of 8 over 16, press arc tangent. What will come out will be 26.56 degrees. Okay? To take the magnitude or the hypotenuse, take the cosine of this. Okay? You divide that to 16. What will come out will be 17.88. It should be automatic using your calculator. You don't have to show it. The second solution for the magnitude is that take the sine of this, you divide that to 8, okay? What will come out should still be the same, 17.88. That's the second solution. And the third solution, if you want the long one, use the Pythagoras principle. Square of 8, the square of 16, you take the sum, you take the square root, what will come out should still be 17.88. So if you are on the board exams, it's your choice of what kind of solution you will be bringing out. Okay, so that's Z1. Z2, it's the same. This is 24. The imaginary part is 20. It should be downward. This is 24. This is minus 20, minus G20. And this is the one we are looking for, the magnitude. And this should be angle theta, it's negative. Right? So actually we could compute for this. Take the ratio of 20 divided by 24. Okay, press arc tangent. It should be less than 45 degrees. This is 37.80 degrees. The sign is negative because this is downward, right? This is the angle is in the fourth quadrant. To get the magnitude, take the cosine of negative 37.80 degrees. You divide that to 24. What will come out should be 31.24. Second solution, take the sine of 37.8. You divide that to 20. What comes out will be 31.24. Also, the last solution, if you would like the Pythagorean principle, take the square of 20, then take the square of 24. Okay, take the sum, then take the square root. What will come out is supposed to be 31.24. It's all the same. But I'm giving you an advice if you are on the board exams, okay, get the fastest and simplest solution possible. Okay, we are buying for time in the board exams. So to find the ratio of C1 over C2 over C2 now, they are now both in polar form. So this is 17.888 angle 26.26 over 31.24. Okay, angle minus 37.80 degrees. And the roll under division, I am telling you now, this will not change. As long as we are living, this concept will not change. The resulting magnitude will be the magnitude of the numerator divided by the magnitude of the denominator. That's the resulting magnitude, right? You do that separately, and the resulting angle will be, it should be the angle of C1, okay? If the operation is division, the operation here should be subtraction, okay? Minus, open quantity, but place the proper sign, negative 37.80 degrees. So this ratio here, it's almost 1/2, 0.5726. This is a minus and a minus, so this 37.80 will be added to this 26.26. So what will come out will be 66.36 degrees. That's the what they call this ratio of C1 and C2 in terms of polar form, but the problem is asking for the answer in rectangular form. So actually, this is 66.36 degrees, right? It is something here. This is 66.36 degrees. So to express it in rectangular, we know this angle, we know the magnitude, 0.5726. Okay, so use your knowledge of algebra, trigonometry, the sine and cosine function. To get the opposite side, okay, take the sine of this multiplied by the hypotenuse, that will be the imaginary part. What they call this, take the cosine of 66.36 degrees, cosine, we will be taking the adjacent side or the real part, times 0.5726. What will come out will be 0.22933 ohms, so that will be our final answer. the answer in the so-called rectangular form. Okay, that's it guys. So for those of you who are taking up electrical engineering, if you plan on getting the board exams, you must have to memorize this by heart. The operation of addition, division, and multiplication of complex numbers. Impedance is a complex number. Okay, without treating impedance as complex number, okay, your answer will be wrong because you could not use the real part. It's a complex number, so use your knowledge of complex number. Okay. Good evening from Los Angeles. This is Professor David Jetelos.